Now I'd like to talk about induced magnetism and ferromagnetic materials. Here I have a piece of iron, and this is capable of becoming a magnet, but in order to make it into a magnet, I need to put it in a strong magnetic field. Let me demonstrate how that works. I'm going to put it in the coil of this, the center of this solenoid coil, and turn the current on and show that now that it's in there, it behaves like a magnet. I can show it behaves like a magnet in that it'll pick up that little piece of iron, whereas when the current is off, then even though it's ferromagnetic, it's not activated and it's no longer a magnet. So the only time in some cases when ferromagnetic materials behave like magnets is when they are in a dominant field here that creates that magnetism in them. So we can make a piece of iron into a magnet by putting it in the presence of another magnet. Whereas other ferromagnetic materials that have a different chemistry are capable of retaining their magnetism even though they're not in a coil of wire, such as this bar magnet here. It's a magnet even without the coil of wire inducing the magnetism. So this we call a permanent magnet, and this we might call a temporary magnet. Both are made of ferromagnetic materials such as iron and nickel, but with the temporary magnet it has to have a field controlling its magnetism to produce that magnetic effect. Now I can demonstrate for a material that's not ferromagnetic, such as a piece of copper. It's a good conductor of electricity, but it's not ferromagnetic. I can show that when I put the copper bar there, that it doesn't behave like a magnet. But again, the ferromagnetic bar, when I place it there, gets pulled into the center of the coil, whereas the copper bar, when placed outside, just kind of hangs and dangles there. Now, an application of this is a solenoid switch. If we have an iron bar and a coil called a solenoid coil like this, and for example, if the iron bar is in this position and I turn on this controlling switch here, then this could go over and close another switch over here, activating another circuit that might be connected to it, and that's the basis of what we call the solenoid switch. Applications of that can be found in ordinary automatic sprinkling systems, in the starting solenoid of our that controls the starting motor of our automobiles when we start them up, and various other places. So the solenoid switch involves ferromagnetism along with a solenoid coil in that fashion. Now we see that the coil pulls the iron bar inside. In a similar way, the bar pulls on the coil, and again we have Newton's third law always active, that if the coil pulls on the bar will also pull on the coil.